In the world of programming and software design, there are several core principles that help developers create systems that are scalable, maintainable, and reliable. Some of the most widely known principles include SOLID, ASCII, DRY, KEYES, YAGNI, GRASP, the 12-factor app methodology, and more. Let's explore each of these in a conversational way, as if we're taking a guided tour through the foundations of great software development. We begin with SOLID, a set of 5 principles aimed at making object-oriented software easier to manage and expand. The first letter, S, stands for the single responsibility principle. It means that a class should have only one reason to change, or in simpler terms, it should do just one thing. If a class handles both data persistence and presentation logic, for example, it's taking on too much. Instead, each responsibility should be separated into its own class. The O in SOLID stands for the open/closed principle. This tells us that our software should be open for extension but closed for modification. That means we should be able to add new features without changing existing code, a concept made possible through techniques like inheritance and interfaces. Next is the Liskov substitution principle, represented by the letter L. This principle states that objects of a superclass should be replaceable with objects of a subclass without breaking the application. In practice, that means subclasses should behave in ways that are consistent with what's expected from their parent classes. The I stands for interface segregation. Instead of creating large, monolithic interfaces, developers are encouraged to design smaller, more specific ones. This allows classes to only implement what they truly need, keeping code clean and focused. Finally, the D in SOLID refers to the dependency inversion principle. This principle suggests that we should depend on abstractions, not on concrete implementations. It leads to more modular, testable code and reduces tight coupling between components. In JavaScript, this means passing in dependencies via parameters or injection, instead of hardcoding them. Shifting from design principles to data integrity, we come to ACID, a key set of properties for database transactions. The A in ACID stands for atomicity, meaning that a transaction must either complete fully or not at all. If you're transferring money from one account to another, the system should either deduct from the sender and credit the receiver, or do nothing if something goes wrong. The C stands for consistency. This ensures that a database remains in a valid state before and after a transaction. It means all rules and constraints must be respected. I stands for isolation, which guarantees that transactions occur independently. If 2 users are booking the last available seat on a flight at the same time, isolation ensures one will succeed and the other will not, rather than both being told they got it. Finally, D represents durability. This assures us that once a transaction is committed, it remains so, even in the event of a crash or power outage. Outside of structured design and database theory, there are broader principles that help guide everyday coding. One of the most famous is DRY, which stands for Don't Repeat Yourself. This principle encourages developers to avoid duplicating logic and instead create reusable components. Duplicated code is hard to maintain and prone to errors, especially when updates are needed. Another widely adopted principle is KEYES, or Keep It Simple, Stupid. The idea here is that simple code is easier to read, understand, and maintain. Overly complex solutions are discouraged in favor of straightforward ones. YAGNI, which stands for You Aren't Gonna Need It, is a principle that advises developers not to add functionality until it's actually required. Writing code based on hypothetical future needs often leads to unnecessary complexity. For more advanced object-oriented design, the GRASP patterns, which stands for General Responsibility Assignment Software Patterns, offer guidance on how to assign responsibilities to different parts of a system. These include patterns such as Controller, which delegates tasks, Creator, which suggests which class should create instances of another, and Information Expert, which recommends assigning responsibilities to the class with the necessary information. GRASP also emphasizes the importance of low coupling and high cohesion, meaning that classes should be independent and their internal responsibilities should be tightly related. For developers building cloud-native applications, the 12-factor app methodology offers a set of best practices. It starts by recommending that applications have a single codebase tracked in version control. Dependencies should be explicitly declared, and configuration should be stored in environment variables. The application should treat backing services like databases and queues as attached resources and should strictly separate the build, release, and run stages. Processes should be stateless and share nothing, exporting services via port binding. Scalability is achieved by using concurrency through multiple processes. Dev and production environments should remain as similar as possible to reduce surprises. Logs should be treated as event streams and not written to disk. Finally, any administrative or management tasks should be run as one-off processes. Another important principle is the law of Demeter, also known as the principle of least knowledge. It encourages us to write code where objects only talk to their immediate collaborators, not strangers. In other words, don't chain method calls through multiple objects. Instead of calling order.getCustomer, getAddress, getZipCode, expose a method like order.getCustomerZipCode. This keeps code easier to refactor and limits dependencies. Lastly, there's CQRS, which stands for Command Query Responsibility Segregation. This pattern separates the system into two distinct parts, one for handling commands, which change state, and another for handling queries, which only read data. It's a powerful pattern often used in complex systems to improve scalability and make responsibilities clearer, but it comes at the cost of added complexity.